Hello friends, welcome to Analog Analyzers. Today we are going to learn about LDO, that is low dropout voltage regulator. So LDO is the linear voltage regulator. There are two types of regulators, linear voltage regulator and one switching regulator. The LDO has the advantage that even if the output voltage that we want to take is very close to supply, then also we can use for it. So it is a linear voltage regulator which can regulate the output voltage even when the supply is very close to output. The advantages of LDO over switching regulators are absence of switching noise, as there is in the switching regulators the voltage will be regulated by switching on and off the diode or the MOSFET, due to which there will be switching noise, whereas in the LDO there is no switching, so absence of switching noise is there. Also LDO are comparatively smaller in size, but the disadvantage associated with LDO is the distribution of power. So for example, if LDO is giving more power output or voltage output than what it is supposed to, it will dissipate that power near the device itself, which is one of the disadvantages of it. And good part is like it can provide constant supply voltage even if the temperature or supply fluctuations are there. So it is so precisely made that even if there is a fluctuation in temperature or supply, it constantly gives it gives constant voltage. So this LDO is basically consists of 4 blocks. First is BGR, that is band gap reference, which provides reference voltage signal. Second is error amplifier. Third is resistive divider network, to which we can also call as feedback network. And fourth is pass device or power transistor, which is called. Why do we need LDO? So like in other regulators like switching regulators, LDO is also used to regulate the voltage, but in major benefit of LDO is can regulate output even if it is close to VDD. The output voltage is ideally stable when line and load variations. With line and load variations, even to change in ambient temperature. So yeah, it is very much. So means not only instability in VDD and VSS, but also even if you change the load, that does not affect the output voltage of the LDO. So let's see quickly about how it works. So you can see these 4 sub blocks rather. This is band gap reference, which provides constant voltage supply. This is resistive network. This is error amplifier, also we can call this op-amp, and this is PMOS transistor, power MOS transistor. So quickly, and this is any load that have connected to the output. Vin, this can be VDD as well, and this is Vout, which is the desired output voltage. So quickly just see the working of it. So in order to understand the working of this circuit, let's take a scenario wherein Vin is 1.8 volt, Vout that we want is 1.2 volt, and this is R1 and R2. After, as 1.2 volt will be on this gate, these 2 resistor networks, this is voltage divider. It will drop some voltage, and voltage at this point is 0.7. just for example we are taking, and here it will be 0. So so if V reference generates a voltage of 0.7 volt, and here also the voltage is 0.7 volt, the error in the voltage will be 0 volt. The output will be 0, and this PMOS will turn on and it will keep working. In other scenario wherein, so that was the normal working, wherein Vout is appropriate, PMOS is giving appropriate voltage. Now in a scenario wherein the output voltage has gone up from 1.2 volt to 1.6 volt, now it has moved out of its range. So what will happen, this resistor will give some drop. Earlier for 1.8 it was 0.7, now for 1.6 take it as 0.9. If it is 0.9 and this is 0.7, the error amplifier will generate a voltage having 0.3 difference. 0.2 difference, and the 0.2 will be at the output of error amplifier, which is going to the gate of PMOS, and due to which it is going towards the resistance of this PMOS is increasing, and thereby it is going towards VDD. So thereby this PMOS will drop more voltage, dissipates more voltage, dissipates it, and give the appropriate voltage which was required.